Hey everyone, how goes it, and welcome back to Computer Science 145. Today, we're going to talk about loops. I'm not going to do that again. In a previous lecture, we discussed looping statements such as a while loop and a do-while loop. There is another very common kind of loop that's called a for loop. For loops can be considered a counting loop, and this can also be considered a special type of a while loop. For loops look a little different from any other statement that we've encountered because the arguments, in other words, the thing that's inside the parenthesis, has three separate parts. The first part can be called the init, and this is the initialization of a counting variable, and this statement runs one time only. The next part is called the Boolean expression, and this is just like the Boolean expressions that we've seen in while loops or even if statements. Finally, the last argument is the update, and this updates the counting variable after all of the other statements in the body have been executed. Each different part of the arguments are separated using a semicolon. As we can see right here, this is the initialization, this is the Boolean expression, and here's the update, all separated by a semicolon. Now, just like everything before, I strongly encourage to use the curly braces in order to denote the body of the for loop. And once again, do not put a semicolon after the parenthesis right here. Now, as we are continuing to learn how to speak to the machines, what you can think of as a for loop is saying, do that for this many times. Taking a look at the flowchart for a for loop, it looks like this. As we can see here, when we enter into a for loop, we run this initialization once only. After that, we then check the Boolean expression. And if that is true, then we run the body of the for, then we update, and then loop back here, which will then check the Boolean expression. If that's true, we'll run the body of the for, we'll update, and loop back here. For loops can be a little tricky to understand only because everything that we've written so far has been line by line, top to bottom. However, if we want to think about these as these individual parts, look at this. The way a for loop works is this can be considered step 1. This can be considered step 2. Then the body of the for loop is step 3, and then the update is step 4. Remember, the update happens last, after every other statement in the body of the for has happened. So if we start this out, this will be 1, 2, 3, then 4. And then when we loop, it checks 2, 3, 4, 2, 3, 4, 2, 3, 4, until this Boolean expression evaluates to false, and we jump outside the body of the for loop. It was mentioned before that a for loop is more or less a special kind of while loop. In fact, if we look at these side by side, this is essentially the exact same thing. Now, as programmers, we are not lazy, we're efficient. If we have discovered that we're writing the same kind of thing over and over and over again, more often than not, we create a brand new statement to make our life a lot simpler and a lot easier. So absolutely, you can use for loops, but if you're more comfortable using a while loop, then use the while loop equivalent. Now, looking back at the flowchart that we just saw, we can see that this represents the for loop. Now let's see what the while loop looks like as a flowchart. It's the exact same thing. So once again, a for loop is just a counting version of a while loop, where we have three different parts: the initialization, the Boolean expression, and this update that are represented in each one of these argument parts. The key thing to keep in mind with a for loop, the init happens once only. Then the Boolean expression, if that is true, we run the body of the for, and finally we run the update. Now with that being said, let's see an example of a for loop. Now one of my favorite animals in the entire world, well besides a cat, is an octopus. Octopuses are really awesome, and if you don't know about how cool they are, definitely read up on how awesome octopi are. Well, anyway, with all of that being said, here's the problem I'm going to solve. So let's say I was having a conversation with an octopus, and this octopus liked math a good bit. And so what it likes to do is basically count all of the numbers that are multiples of 8 until a given number that I give it. Now, as absurd as this sounds, we're going to use a for loop in order to do this type of problem. So let's go ahead and get this started. I'm going to start by creating myself a new class, and I'll just call it the octopus problem. I'm going to include my entry point in the main method. Here we go. And also put my name at the top here. Now, as I'm interacting with this octopus program, we need some form of user input. So we're going to import java.util.scanner. That way, we can set up inside of the entry point, scanner keyboard equals new scanner system.in. Now, after we've set this up, the octopus program is going to prompt the user. System.out.println. I'm an octopus, so I like the number 8. Enter a positive value, and I'll count up by 8s. Blub, blub. That seems like what an octopus would say, why not? So now we need the user input. And let's just assume that they're going to be entering in whole numbers. So we need to go ahead and create a variable to store that value. So let's create an integer, as we know those are whole numbers, and just call it number input. Then, in order to get the information from the console, we're going to assign this to keyboard.nextInt to get the next integer value. Now, after that, we have to pay very close attention to what is being said here. Enter a positive value. Now that we understand about decisions, we need to be able to check for errors. And this becomes so very important in computing, is being able to check for valid values. So if the user enters a negative value, then we can't really do anything with this. So we do need to check if the number input, if this happens to be less than 0, so a negative value, then we should prompt the user system.out.println. That's not valid. And we need to immediately stop the program, system.exit. Now, if this were not true, that means we did enter a positive value. So now we can use our counting loop, a for loop, in order to determine all of the numbers that are divisible by 8 up until this number that we entered. So let's start like this. 4. Then we're going to put our arguments. The first thing is the init, the initialization of our counting variable. I'm going to keep this simple by making it into an integer that we call I. And we'll go ahead and assign this to 0. Now, putting the semicolon, we get to the next part of the argument, which is the Boolean expression. So think of it like this. While I is less than the number input, we're going to keep running this loop. Then after that, we have to update the value of I. And for argument's sake, let's just increase it by 1 each time. I plus plus. Then we write the curly braces to denote the body of the for loop. Now the next part is we need to basically print out all of the numbers that are divisible by 8. In other words, all of the counting values, all of the i's that are divisible evenly by 8. We cannot simply just print out all of the I values because not all the values are divisible by 8. The way that we can determine this is by basically finding whenever this value has no remainder after division, then it is divisible by 8. We understand that the mod operator gives us the remainder after division. So if we take if I mod 8, this will give us a remainder value. Now, if we have no remainder, then it was perfectly divisible by 8. So if I mod 8 is equal to 0, no remainder, then we know that this I value currently is divisible by 8. Inside the body of the if, we will system.out.println the variable I. Now, let's see if this works. Running our program, we're prompting the user, and I'm going to enter the value 100. Well, there you go. Starting from 0, it counts up by 8, and these are all the values that are perfectly divisible by 8. Remember, the way that this worked is this initialization happened first, but once only. Then, we check this Boolean expression, run the body of the loop, and then increase it by 1. So again, if this is 1, 2, 3, and then 4, then 1 happens once only, then 2, 3, 4, 2, 3, 4, 2, 3, 4. And this just keeps increasing the value of I by 1 each time. Now, there is an alternate version of how we can do this. And what I'm going to do is not erase this code. I'm going to create a block comment around it. Now, one piece of programming advice that I can give is if you think of a better way in order to write something, don't erase the code. Put it in a comment for right now. That way, if the plan that you thought was better ends up not really being better, then at least you had the code that worked. Now I'm going to write another for loop that's going to do the same thing, but in a slightly different way. So we start out with for, and then we denote our arguments using the parenthesis. The first part of this is always going to be the initialization. So again, I'm going to initialize an integer I and assign it to 0. Once again, we're going to keep running this loop while I is less than the number input. Now, instead of I++, in other words, increasing I by 1, we could simply increase I by 8. We know if we increase the value of I by 8 every time, then yes, all of the values calculated are divisible by 8. So instead of I++, we can simply do I plus equals 8. Then we create the body of the for loop. However, this time, we don't need to mod the value, as we know we're increasing this by 8 each time. We can just simply system.out.println I. As we are increasing it by 8 each time and we're starting at 0, all the values will be divisible by 8. So running this once again, if I enter 100, it gives me the exact same values, but it's done in a slightly different way. There's multiple different ways to solve these problems, and I strongly encourage that everyone try different ways to solve them. Now, just like while loops, if statements, and all of those, we can have nested for loops. Let's take a look at a nested example of a for loop. Here's our problem. We're going to prompt the user for a length and a width, and then we're just simply going to draw a box in the console corresponding to that length and width. So once again, we're going to go ahead and create a new class, and I'm going to call it drawABox. Include the main method, our entry point. Then I'm going to write my name at the top here. clean this up a little bit, and we're also going to import java util.scanner, as we know we're going to have some kind of user input. And inside of our main method, we're going to set up the scanner, scanner keyboard equals new scanner system.in. After we've done that, we need to go ahead and prompt the user, system.out.println. I can draw a box using stars. Give me a length followed by a width where both are greater than 0. Let's just assume that we can't draw a box with a 0 length or a 0 width. Now, entering down here, let's go ahead and create the variables to store the length and the width. First, int length is equal to keyboard.nextInt, followed by int width equals keyboard.nextInt. Now, as we have prompted the user, we've also said that neither length or width can be less than or equal to 0. We need to check for valid values. So if, for instance, the length was less than or equal to 0, or the width was less than or equal to 0, if either one of these were true, we cannot draw a box. This is why we need to use an or instead of an and. Now, if this compound Boolean expression evaluates to true, then this is invalid. System.out.println, that is invalid. And we need to immediately stop the program. System.exit. Now we get to the difficult part of being able to draw this shape, being able to draw this box. One idea that's been brought up several times is problem solving always involves mapping your knowns to your unknown. So what do we know about the console? Well, first of all, the console always works like this. It adds value left to right first, then top to bottom next. So assuming that, we need to handle all of the left to right elements first, and then jump down and go top to bottom. Here's how we're going to do that. We're going to first write this for loop to correspond to the length of the box. For int I is equal to 0. I is less than the length, I++. So we initialize this counting variable to 0. We keep running this loop while I is less than the length, and we increase I by 1 each time. Keep in mind, the length is drawing the element top to bottom, which needs to happen after we draw the stars left to right. So inside the body of this for loop, we're going to write another for loop. For int j is equal to 0, j is less than the width j++. Now we need to use a different variable here. That way this loop corresponds to the I and the length. This one is different, it's j corresponding to the width. Now once again, we know that the console prints things out left to right first, then top to bottom. So what we're doing here is printing out the elements left to right first inside of this different loop. So inside of here, system.out.print, not print line. We're not adding a new line to this, we're printing this out left to right. Inside of here, we're just going to put the asterisk. Now we're not quite finished, because outside of this inner for loop, but inside the outer for loop, we can then call system.out.println. We can leave the arguments of this method empty, as all this is doing is adding the end line. So now looking at this, we first print out this many stars corresponding to the width, jump down to the next line, print out this many stars corresponding to the width, jump down to the next line, and we keep doing this whole process until we've done everything by the length and the width. Now, let's see if this works. Running our program, we're going to make a box that is 2 by 3. And there you go. The length was 2, the width was 3. Now, as this example can be a little confusing, let's take a closer look as to what's going on here. We have our code snippet to the side, and then we have these variable values over here. Let's look at what happens as we're running this program. Assuming that we're following the exact same example with the values that I entered in, let's see exactly how this works. Now pay very close attention that both the variable I and j currently do not exist. Variables do not exist until they have been declared, and that variable only exists inside the body in which it was declared. This means for a for loop, the values I and j only exist inside of this body for I and this body for j. Let's start running this. When we first approach this line, we know that we initialize first. Now we can see that the value of I has been declared and assigned to the value 0. Then we check the Boolean expression. I is 0, length is 2. 0 is less than 2, that is true. After that, we run the body of this loop, which then jumps down to here. Now j exists, as it has been declared and assigned the value of 0. Then we check the Boolean expression. J is 0, width is 3. 0 is less than 3, that is true. So then we enter the body of this loop. Once we jump down here, as you can see in the console, we print out 1 star. We've run all of the statements inside the body of this loop, so then we update the value of j, increasing it by 1. Then we check the Boolean expression again. 1 is less than 3, so we run the body of this loop, then we update making j 2. Then we check the Boolean expression. 2 is less than 3. We run the body of this loop, we update the value of j, check the Boolean expression. 3 is not less than 3, that is false. So then we immediately jump outside of that inner for loop and then run the system.out print line. We won't see the effect of this print line until we get back to that for loop, but do notice that once we are outside of that for loop, the value of j no longer exists. The scope of the variable, in other words, where a variable is valid, is only where it is declared. Inside of for loops, our counting variable only exists inside of this body. Once we're outside of it, it does not exist. So now we've run the body of that outer for loop, and finally we can update the value of I, which becomes 1. Then we check the Boolean expression again. 1 is less than 2, so we jump inside of here. We redeclare j as assigned to being 0, and then we check the width again. 0 is less than 3, so we run the body of this, start printing that out. A few steps later, we end up with our result. There is a lot of concepts here, but one of the main ones to always keep in mind is the nature of how a for loop works. First, the initialization happens, and it only happens once only. Then we check the Boolean expression, then we run the body, and then update that counting variable. And even if it's nested, it does the exact same thing. This initialization happens once at first, then we check the Boolean expression, run the body, update, check it again, run the body, update, and we just keep doing in this loop. And then we also do the exact same loop here. And this is how we can draw shapes inside of a console. We've explored several different kinds of loops in these past couple of lectures, and each one of them can be used in different ways. So looking at these a little closer, we understand that a while loop, the body of it may run 0 to many times. While loops are excellent for using what's called an ask before iterating strategy. If we don't know exactly how many times the body needs to run, then we may need to use a while loop. In contrast, a do while loop is similar to a while loop, but the body of the loop runs at least once. This type of loop is also great for ask before iterating. But in this case, we know that the body needs to run at least one time before we ask before iterating. And finally, the for loop is great when we know the number of times that the body of the loop needs to run. A for loop is a counting loop, or a count-controlled loop. These are all the different ways to use these kinds of loops, and keeping this in mind can help us solve problems in a more efficient way. Now, a few other details involving loops. There's a special statement called the break statement. Whenever the break statement is encountered, it immediately stops the loop. You can think of this as the break statement, when it is reached, it will jump outside of the entire body of the loop. So if we look at this example, where we set this value a here, if a is greater than or equal to 5, then we break. So starting with 0, 0 is not greater than or equal to 5, so we print out 0, then increase it by 1. So 0, 1, 2, 3, 4, and then we get to 5. 5 is greater than or equal to 5. We break, so we ignore the rest of the body and end up out here. Now, in a situation where we have nested loops, the break statement only breaks where it is found in the body. So if it's in the innermost loop, it only breaks the innermost loop. A similar kind of statement is the continue. What this does is it stops the current loop iteration and then restarts a new one. So instead of jumping out of the loop, when the continue statement is reached, it jumps back to the start of this loop and starts running it again. In our example here, if we set a to 0 and while a is less than 10, we increase a by 1 first. So in this case, if it starts at 0, a++, now a is 1. A mod 2 is equal to 0. So 1 mod 2, that's not equal to 0, so we ignore this, and then we print out the value 1. Then we loop back. 1 is less than 10, a++, in other words, a becomes 2, 2 mod 2 has no remainder, so then we jump to this continue and then jump back to the start of this loop. 2 is less than 10. A++ now makes a 3. A mod 2, 3 mod 2 is equal to 1, so we ignore this and print it out. And this is why the output becomes 1, 3, 5, 7, and 9 before it stops here. Now, just like a break statement, when it comes to nested loops, continue only continues in the innermost loop that it is found. And finally, there's a very special concept that we use a lot in programming called sentinel values. Sentinel values are very special kinds of values that are used to signal the end of an algorithm. Now, in reference to this, we can use sentinel values to stop a loop. The main concept of a sentinel value is they should be selected so that they are distinct from all other valid values. To explore this idea, let's take a look at this example. We're going to find the average of positive values. And as we know, in order to find the average of something, we need to add together all the values, in other words, sum them together, and then divide them by the number of values that we have, in other words, the count. Now, looking at this code snippet a little further, we see while true. Oh, but wait a second, this would cause an infinite loop because this will never become false, it's always true. However, notice that we have a break statement inside of here, and this will break whenever the value entered is less than 0. Once again, we are finding the average of all positive values, so we're using sentinel values that are negative. Whenever the user enters in a negative value, it will stop this loop. So if we have this example right here, let's step through it and see how it'll work. First, we assign all these values to 0. While true, well, true is true, so we enter here. Now, if I were to enter the value 2, value now becomes 2. 2 is not less than 0, so we add 2 to the sum, and sum becomes 2, and count becomes 1. Looping back up here, now we enter the value 4. 4 is not less than 0, so we add the value 4 to our sum, making sum 6, increase the count, which is now 2. Loop back here. Now we enter the value of 6 inside of here. 6 is not less than 0. Then we add this to our sum, which is currently 6, so 6 plus 6 makes it 12. Increase the count by 1, now it is 3. Loop back here. Now we enter the value 8. 8 is not less than 0. Then we add 8 to 12, making the sum 20. Increase this by 1, so it makes it 4. Then we loop back here. We enter the value 10. 10 is not less than 0. 10 plus 20 equals 30. Increase the count by 1, which is now 5. Loop back here. Now we enter the value -1. -1 is less than 0, so break happens, and we immediately jump outside of this loop and start running these statements. Our sum is 30. Our count is 5. This means the average is 6, and we print out the value 6 here. Using sentinel values is a technique that we can use to solve a lot of problems that involve loops. If we have a special condition that we need to stop on, then we can use these special values in order to do that. In this lecture, we've focused on the for loop, and we've explored several different problems involving the for loop, while also introducing the ideas of a break statement, continue statement, and also sentinel values. Now, with all that being said, I'll see you next time.